All right, everybody. Well, hello, good evening. Welcome to Louisiana's Old State Capitol. We're so happy to have y'all here with us tonight for this special event. It is part of our mission as a Secretary of State museum to educate the public on Louisiana's history, and sometimes that includes our geological history. So we're very excited about this talk to complement our traveling Smithsonian exhibit, Waterways, which will be on display in our temporary exhibit gallery until August 9th, which is a Saturday. So if you didn't get a chance to see it tonight, please make it a point to come back and see it anytime we're open. I want to give a couple of thank yous. First off to CWPPRA for coming out tonight. To combat coastal land loss, the Coastal Wetlands Planning, Protection, and Restoration Act was enacted in 1990 by the federal government to identify, prepare, and fund the construction of coastal wetland restoration and protection projects. In addition to coastal restoration projects, CWPPRA also provides community outreach efforts to share information on Louisiana's land loss crisis, the need for coastal restoration, and the value of the CWPPRA program. Now, for tonight, we have a wonderful speaker with us, Jacqueline Richard. Jacqueline Richard is the director of the Coastal Studies and GIS Technology at Nunez Community College, with 18 years of education and advocacy experience. By focusing on education surrounding the complexities of Louisiana's coastal issues, Jacqueline has developed curriculums at the middle, high school, and college levels to bring awareness to the forefront. She received Volunteer of the Year in 2022 and a Coastal Stewardship Award in 2024 from the Coalition to Restore Coastal Louisiana. To support the development of Louisiana's sustainable energy options, she has recently helped develop the new Wind Energy and Technology program at Nunez. Jacqueline's passion is getting out into the wetlands, teaching about these fragile ecosystems, and planting trees to help save the coastline. With the conclusion of this program, we do have some program evaluations that can be found on that back chair in the back rows. If y'all wouldn't mind taking a couple minutes, we always appreciate it when y'all fill those out. Let us know what you like, let us know what we can improve upon, and let us know what you'd like to see for future programs. And then lastly, I also want to make a special announcement. We will be open this Friday, 4th of July. And so we invite you all to come out to the Old State Capitol and have a picnic with us. So without further ado, I'll go ahead and hand things over to our speaker for the night.
Good evening, everybody. I'm really excited to be here and really excited to be invited to speak to you all tonight about my passion, which is rocks. So I will tell you, my level of excitement won't really die down. I drink a lot of coffee, like I tell my students. So you all are just gonna have to bear with this level of excitement all the time. So as mentioned, I'm over the coastal program at Nunez. So I have an interesting history as far as education goes. I'm a deep time geologist. So my formal training is looking at the Cretaceous and Jurassic rocks, which we don't have here. So when I came to Louisiana, I came here, studied paleontology, and then Katrina hit, right? So here we are at the 20th anniversary. And I decided to use my geology knowledge for good and kind of switched into the coastal realm and really tried to bring a lot of awareness and education. So you'll see in this talk that we're going to dive into tonight, it's an interesting mix of deep time and current time, and we're going to see how it all works together. Maybe. Point it back that way. Mm-hmm. Well, we can switch to this. Okay. All right, now slide, please. This is just like when I was in college. I had to, my college professor used old school slide projectors and I was his advanced person. So it's just a nice little throwback. So Slide. Thank you. So we're going to take a look this evening at the deeper time geological history. And we're going to start our story and go back about 260 million years. If you've learned about the coastline, heard materials about the coastline, you've really heard a lot about the last 10,000 years. So I'm going to challenge all of us, and we're going to kind of go back in deeper time. And so I'm going to take this. I'm a wanderer, so you're going to wander with me through time and physical space, right? So we're going to start our story down here at the bottom. We're going to start with the breakup of Pangaea and see how the Gulf formed, because that is incredibly important to our history and especially our energy history here in Louisiana as well. I am not going to give you the full rundown of all the rocks. You can all take me online for a class. You'll hear everything then. I'm going to give you kind of the highlights as we go through. And then we're going to end with the modern story. And then we're really going to kind of take a look and see what happens when people live with water and what happens when people live without water, right? Keeping water at bay, and see how that plays out. Slide, please. So we're going to start with Pangaea, right? So a little bit further back in time. So when Pangaea formed, you can see up at the top there, right? It was our supercontinent. Louisiana, no surprise, didn't exist, right? We were underwater because our story is a water story all the way around. The Mississippi River, we're going to see here in a few minutes, built all of this land, right, from the tip of Illinois all the way down. And so in order to get there, we have to figure out, when did the Mississippi River really start flowing to the Gulf, right? That's kind of the important question. So if we take a look at these bottom pictures, for most of Earth's history, we've lived in what's called a globally warm climate, right? We lived in this temperature maximum, and there was an epicontinental seaway sitting in the middle of our country. I did my undergraduate research at University of Kansas, and we got to go out and we were discovering giant 30-foot-long fish, right, in these chalk hills in the middle of Kansas, right? These are deep water fish. So definitely tells you, right, things were different at points in the past. And as we move through time, there was, I will spare you all of the geological details, but there was a lot happening, right? We were building the mountains out in the west, right? The Rocky Mountains. Our continents were shifting and moving into the places that they're at today. And with that, right, the epicontinental seaway started to move away. As soon as Antarctica got over the South Pole, we start to see sea levels drop. And with that, honestly, really comes the start of Louisiana. Slide, please. So when the Gulf of Mexico opens, South America kind of used to be shoved up here, right where we are. Like I said, Louisiana wasn't anything yet, right? We literally didn't exist. We didn't even have any rocks here to stand upon, right, at this point in time. So we first have to get the Gulf. And as South America starts to break apart, we start to get this opening. Now, this is an important part because this is going to lay the groundwork for all of the future energy production and rocks afterwards. So when this narrow, skinny ocean started to open, it was a very hot climate at this point in time. And if any of you have ever owned a fish tank, you know what happens in a hot, dry climate to your fish tank. The water goes down, right? You have to put new water in all the time. So as a result, as it started to open, all of the water that was down there would evaporate. And the main mineral that we leave behind, right, during evaporation is salt. And so we're going to talk more about that in a little bit. But our entire basement of the Gulf, I know we don't have basements here in Louisiana, right? But the bottom, right, the whole basement is all salt. And that's going to be really important later on. Slide, please. So as this opened, you can see here this bottom picture on the left. So the area that's in purple there is where that salt started to form. And this salt today is located 6 miles below our feet. It is deep, right? Very deep down there. Now, the thing about salt is it doesn't like to stay still. It's really low density, right? So when you push down on salt, it wants to come up, just like water does. And so if you look at that top picture there, you see all those kind of purple columns going up to the top. That's what we call a salt dome. I'm sure you've heard that before, or maybe been to Avery Island, right? On top of a salt dome. Well, what's really cool, and you could think about this the next time you go to Avery Island, is that salt dome is anchored 6 miles below your feet. That's pretty cool, right? At least in my very heavily biased opinion, that's really cool. So if you want a good visual for what the Gulf looked like when it started to form, we can think of that last picture over there on the right side with the Red Sea, right, between Africa and Saudi Arabia. Those two continents, if you look at the shape of their coastlines, they used to be connected, right? They were one continent. But plate tectonics does its thing, right? And these two continents separated, and you get this shallow, skinny ocean, right, that started to form, right, the Red Sea. It'll continue to get bigger. If we were to look 200 million years in time, it's going to be a nice big open ocean, just kind of like the Gulf is today. But that's exactly what our original Gulf looked like, right, when it first started to form, and all of these salt layers started to form as well. Next slide, please. So how does this relate to the Mississippi, right? Well, the Mississippi is huge, right? It drains 3/4 of the United States. And when we had an epicontinental seaway sitting there, you know, if you've ever watched Finding Nemo, right? You know, all rivers lead to the sea, right? It's a dated reference, but my students like it, right? So at that point in time, the Mississippi River was going into, right, that epicontinental seaway. Well, as the mountains started to form, as the Gulf started to open, that epicontinental seaway moved off of North America, it dried up, and the Mississippi River started flowing south, right, down to reach its new terminus, right, its new end, which is the Gulf. Now, it didn't come here at first by any stretch because, again, we didn't exist. The original delta was at the tip of Illinois. If you've ever been to Cairo, Illinois, that's where the original delta is. Think of how far that is, about an 8.5 hour drive from here. I like to go there a lot. It's a beautiful confluence. If you've never been there, definitely take the road trip one day. There's cypress trees there. It's really kind of almost hard to believe, right? That it feels almost like home, right? When you're up there. But if you take a look at this colorful picture here on the left, what you're seeing there with those bands of color is sea level slowly dropping as we move through time, right? We know just in general, as we go from the time of the dinosaurs all the way through today, we have glacial time periods, right? And so sea level is going to drop as we go through time. And that's what you're seeing with those bands of color, right? That's sea level, that's your beaches, right? So if you wanted to go to the beach in the, Cretaceous, you'd go all the way up to those gray areas. You wouldn't come down here, you'd have to take a boat, right? So the Mississippi River built everything from that tip of Illinois all the kind of way down here. We call this the Mississippi River embayment. It's just like Mobile Bay, if you've ever been there and looked at it, just way bigger on a much grander scale. And so what you can see there on the right is that the Mississippi River making this big switch, right? After the extinction of the non-avian dinosaurs, we have the Mississippi River draining down here. Slide, please. Now, just to give you a little bit of highlights about how much our ecosystem has changed, right? Because Louisiana has to exist at some point, right? Above the water. So we know the bottom is going to be salt. And we've got all these layers on top. Well, one of my favorite layers, again, heavily biased as a geologist, is limestone. I think limestone is cool. I originally grew up in Illinois, way further than the tip of Illinois, way further up. And I collected lots of fossils from limestone when I was a kid, so I kind of have a soft spot for it. But limestone is cool because it is almost like having a decoder ring. This is the beautiful part about geology, is we can look at rocks and what's contained in them and completely understand what old environments were like. So here we are, 145 to 100 million years ago, and we can take a look at these rocks that are made of limestone. Now, limestone is a rock that only forms in coral reef environments. It doesn't form anywhere else, right? So in coral reef environments, you're going to have lots of life, lots of fossils that are there. But I want you to think of how specific a coral reef environment is, right? Do we have coral reefs here? No, right? We have them way over to the west side of Louisiana. There's a small one way, way, way over there, way out. But we don't have it here because the Mississippi River has too much sediment, right, in it to support a coral reef. But if we think here in that blue area that's shaded, that's where we had coral reefs, like I said, 145 million years ago. So we were much closer to the equator. We were much warmer, clear water. Think of the Bahamas, right? Definitely a different environment. And these are important rock layers because they tell us, like I said, specifically about the animals and the life that was there. Slide, please. This is going to be a whole bunch of slides. So back there, if you want to kind of go through here every 15 seconds or so, please feel free. Because what we're going to do here, I'm not going to go through each little piece, but we're going to watch these rock layers, these colored layers up there to the northern part of the tip of Louisiana. We're going to watch it, what we call, say, prograde. So the Mississippi River is building outwards, right, as we go. So here you can see, right, we have more material coming down. You can see the Chicxulub depression down there. That's the asteroid, right, that killed the non-avian dinosaurs. But now you can start to see the Mississippi River Delta up there. It's kind of labeled in that brown hashed area. But all of these rivers are now starting to work their way through. Feel free to keep going. I got a bunch of these little slides coming. But what I want you to notice here, you can see the tip of current Louisiana, right, the tip of Plaquemines Parish, which is, by the way, where I live. I live about 30 minutes from the bottom, right, of the river. And you're going to watch as this continues to prograde, and it's going to build even further, right, than where it is today. And I wish we had this problem still. I wish, right, we were still building way further out because we would have so much land and so much coastline. Perfect. Thank you. So that was kind of your fast forward 260 million year history till about 7,000 years ago. You guys feel good? We just time traveled a whole lot really, really quickly. But basically, like I said, the story is just the Mississippi River building its way out, right? Which it's still currently building today. Unfortunately, not so much in the modern Delta area, but over in the Wax Lake Delta. But this brings us to the modern Delta, right? The last 7,000 years, and has built the land that we are on today. Slide, please. Now, what's really interesting and really cool is not only has it built, the southeastern portion of Louisiana, but it's built the entire coastline, right? So we divide our coastline up into two pieces, right? The deltaic plain, which is where the delta is, right? When the river enters out to the sea, the velocity of the river slows down really fast, right? The Mississippi River is almost like plumbing in your house. It's in a little pipeline and it's moving real fast. Well, the Gulf isn't moving very fast, right? So when that fast water hits the slow water, it slows down and it can't carry all of that sediment anymore, right? And it drops out and it builds and it moves its way along the coastline. Well, that sediment doesn't just stay in the deltaic plain, it works its way all the way to the western part of the Gulf, right? We call that longshore drift. There's your $5 science term for the evening. And basically, it's just a conveyor belt, right? The way the waves move in the Gulf, it just picks every grain up and slowly works it, right, all the way to the west. So the western part of Louisiana is the Chenier Plain, which has been built by that sediment. Slide, please. So we're going to just kind of here take a quick look at our last 7,000 years or so and the deltas that have formed. So the oldest in this more modern delta complex is the Maringouin Delta. During this time, sea level was rising pretty quick. We were coming out of that last ice age. So those glaciers were melting and sea level was rising. This delta is going to be later buried here, you'll see in a minute, by another delta. They kind of stack on top of each other. So if you want to envision a loose water hose in your backyard, kind of whipping across your backyard, that's what the Mississippi River does, but a little bit slower, right, than your garden hose. This delta builds what's called Ship Shoal. If you've ever heard of that, if you've ever listened to some coastal stuff and you hear that term kind of thrown around, this is the delta that built that far out ship shoal area that we use a lot of sediments for in coastal restoration. Slide, please. The next is the Teche Delta. So what I want you to know, if you've ever been right on the Teche, right, that's the old channel of the Mississippi River, right? It was later abandoned, right? Because again, what happens is you can see how these deltas get really long and they become kind of inefficient. The river wants to get to the Gulf as fast as it can, right? Water rolls downhill and it wants to do it quickly. And so as these deltas get longer and longer and longer, it's going to eventually pop out the side, right? And find a faster way to the Gulf. And we call that an avulsion. And we're going to talk about that in a little bit. But basically, right, that's just the delta moving back and forth. So this forms between 5,500 and 3,500 years ago. Sea level was lower than it is today, but still rising. We're going to go through periods of waxing and waning, right, where sea level comes up and it goes down and comes up and goes down. All right, slide, please. Then we have the St. Bernard Delta, which forms where I teach, right? So thank goodness for the St. Bernard Delta. But the St. Bernard Delta, you can see how long and skinny it is. This helps form Lake Pontchartrain. This is what closes off Lake Pontchartrain that used to be part of the Gulf itself. And what's really cool about this, if you've heard of the Chandeleur Islands, or maybe you've been there, if you haven't, definitely it's worth chartering a boat. It's beautiful, beyond beautiful. But I want you to notice that where the Chandeleur Islands are going to be are at the very edge of this delta, right? So this was solid, we're going to say solid in air quotes because it's marsh, right? An estuary, but solid land all the way from New Orleans to the Chandeleur Islands. Eventually, right, it's going to move to form another delta. Slide, please. So the Chandeleur Islands, all of these islands that we have along our coastline, all mark edges of barrier islands, right? They're not just there because they look great, right? Who doesn't like going to Grand Isle? Grand Isle is great. But it's there because it was the edge of a delta, right, at one point. And so the Chandeleur Islands, right, you can see as the delta builds out, it builds these, right, it creates the edge of the delta. And as the delta starts to degrade, meaning the delta is going to switch to a new spot. When it switches, you're not getting as much sediment that's staying in that same place. So it's not rebuilding the land, right, quite as fast. And so it starts to fall apart from the inside and it leaves behind, right, those islands. Slide, please. So after the St. Bernard, we get the Lafourche Delta, which formed about 2,500 to 500 years ago. So this is what creates all of the bayous, right, in Terrebonne and Lafourche Parish. So I cannot name all 5 bayous. I should. I worked in Terrebonne for a while. But all of those bayous are really important distributaries from the Mississippi River that we've unfortunately disconnected. But Bayou Lafourche, if you've ever been along Bayou Lafourche, driven down to Grand Isle, that used to be the main channel of the river, right? Isn't it really kind of amazing? To me, it just gives me a new perspective, right, when I drive by these things. But it built pretty far out, and this is what builds Grand Isle. Slide, please. So here is kind of just a nice little overview of all of the barrier islands, which are all, like I said, marking the edge of that delta. So the Lafourche Delta kind of moved a little bit, it wiggled, and it created these barrier island chains. And like I said, there's some great fishing along most of these. But if you go to Grand Isle, I said you're going to the edge of the Lafourche Delta. Okay, slide, please. Then we get to our modern delta, right, which is the Plaquemines Delta. This has really formed over the last 1,500 years or so, which if you've paid attention for the time span of how long it takes these deltas to build, we're kind of getting to the end of what would be a normal delta cycle, right? Deltas last, about 2,000 years or so before they switch, right, and move to another spot. And we're kind of nearing that point. Now, we're going to talk about disconnecting from the river here in a little bit and the importance of why we need to be connected to the river. But what I want you guys to notice is how far south the Plaquemines Delta goes, right? It goes to the edge of what we call the continental shelf. So again, I'll bring back Finding Nemo, right? When they go out there and they go to the deep spot, right? They go to the edge, right? That's the edge of the continental shelf, right? The deepest part. And so we have levied up the river in the sense that it can't build, it can't move back and forth anymore. It can only build outwards. And so all of that sediment that builds our land is now just getting jettisoned off right into the Gulf of Mexico, making it a 0.5 millimeter shallower, right, every year. So the current delta isn't really forming much land anymore, right, because we're keeping it locked in place. Okay, slide, please. So let's talk about the western part of the Louisiana just for a moment to talk about the Cheniere Plain. So Cheniere means a place of oaks, right? So oak trees love drainage. They love being a little bit higher. They like being on ridges and they like having nice drained soil. And so we're going to see that the Cheniere Plain is these alternating ridges, high spots and low spots, right? With oaks, right? Lining those ridges. And these cheniers became really important in shipbuilding a little bit later on in time when we started building ships here in the United States, because live oak trees grow pretty slowly and they grow for a long time. And so they've got really tight weave on their wood, which made them really great for building ships. If you've ever heard of the shipwright Old Ironsides, right? It was called that because it was made from live oak wood. And they could literally shoot cannons at it and the cannonballs would bounce off the ship, right? Now we'd be hard pressed to find trees like that today, right? Because our environment has changed and they're not growing as slowly, right, as they used to. All right, slide please. So just to take a look at how these cheniers form. So it's kind of in 3 steps. So you're going to get what's called a prograding mudflat. So prograding just means building outwards, right? Building towards the ocean. And it's literally just a mudflat, right? So right below the water, you've got some small sediment grains, right? Clay and silt that's getting deposited. And it's going to kind of get reworked. And it's going to be what we call emergent land. This is really important stuff today because this is what we work on in coastal restoration, right? Is to build new land. And so, right, you get new sediment that's working its way from the deltas. So when you guys saw the delta kind of switch over to the west, like the Lafourche did or the Teche Delta did, that would supply more sediment over to the west and would start building these mudflats. And then when the delta would switch over to the east, it wasn't getting as much sediment. Slide, please. So what would happen is when the delta would switch over to the east, it would be starved of sediment and you would start to get reworking, right, of the sediment that's there. Okay, we kind of rework it and move it around. And they said you get less sediment that's coming from the delta because it's just further away. Okay, slide please. And then you'd start the whole process over again, right? When the delta would switch back over, you get more mudflats forming. And right there, smack in between those 2 mudflats, you have this reworked ridge. Now, if you guys ever play with Google Earth, which if you haven't, I suggest you do, it's the easiest and fastest and cheapest way to travel, right? You can look at the world and see all kinds of great things. But if you look to the western side of Louisiana, you're going to see these ridges, right? You'll see these kind of dark green lines. That's that cheniere, right? That's that little squished part in between these mudflats that got reworked that supports the oak trees. Okay, slide please. Now that you've gotten a little bit of geologic history, right? Now that you're geology experts, we're going to see how we've chosen to live, right, with this place. So before Europeans got here, right, there was indigenous peoples living with water, right? We're going to talk about this in a moment, but you can see the map here and kind of how it was divided up, right, between the tribes. Okay, slide, please. So just to take a look at a couple of indigenous tribes that are close to where I'm at, we have the Chitimacha. They lived in the coastal region. They lived in Bayou Teche from about 800 BC all the way till today. They once encompassed the entire Atchafalaya Basin, which that is by far, if you've never been on a boat in the Atchafalaya, my favorite place in the world. It's absolutely beautiful. But it went from the Atchafalaya up to Lafayette, all the way down to New Orleans. So a very large area. And they leave behind incredible ceramics and basketry that's really woven with a lot of their deep origin stories, right? They thought that the basket weaving was given to them from God, right? And so they tell their stories with their basketry. It's really beautiful. Slide, please. Okay, then we have the Pointe-à-Chien, which, sorry that it's a little bit hard to read up there. I love to put in all my references. This is like the scientist in me, so that's like a live link to their tribal page. But the Pointe-à-Chien descend from 3 different tribes, and they live along Bayou Terrebonne, Bayou Lafourche. They originally lived further south until these bayous got disconnected from the river and started shrinking, right? Because they weren't getting fed all of the sediment anymore. So today, some of their ancestral lands are just underwater. They're just gone, right, at this point. They built palmetto houses, which are really incredible. And just to put a little bit of social history in there, because again, I taught in Terrebonne for a while, and it's always incredible to me because you hear this history and it feels like it's so long ago, but they were prohibited from attending public high school until the 1960s and 70s. That's really not that long ago, right? So it always amazes me how close in time, right, these histories are. Okay, slide, please. Okay, then we have Ile-de-Jean-Charles, which you've probably heard of this community if you've not been down Island Road. But this is a community that's being resettled right further inland. But this is, again, 3 different tribes in Terrebonne Parish. And this is kind of the tribe that's at the forefront of a lot of coastal land loss, sea level rise, and environmental justice issues, right? Because they want to live in their ancestral places, and a lot of those ancestral places are getting washed away, right, at this point. If you are into reading books, there's a really great book called Cajuns on the Bayou. It was written in the 1940s about this woman who was traveling and wanted to find an original Acadian, which the joke was on her because Acadians reproduced so much that there wasn't any like original bloodline left, was kind of the conclusion she came to. But she's got some beautiful descriptions of what it was like taking a canoe down to get to Ile-de-Jean-Charles. So if you're into those kind of depictions, it's a really fantastic book. Okay, slide, please. And then we have, this is a tribe that's really close to where I live. This is Grand Bayou Village. Again, 2 different tribes here. They're the only tribe that is accessible by water only today, which makes them incredibly vulnerable. This entire community was wiped out during Hurricane Katrina. It was very fortunate that the Mennonites came and helped them rebuild their homes, because there's a lot of issues with getting federal assistance, because these tribes that I just listed, none of them are federally recognized, which means they are not eligible for federal aid, right? So like I said, this community was completely wiped out, rebuilt, and now we're doing a bunch of coastal restoration work there. I was helped build a living shoreline around some of their indigenous sites that are kind of way further out, and then around their community to help protect it from storm surge. Okay, slide, please. Now there's a deeper connection, right, to water. Have any of you guys been to Poverty Point? Excellent, good. Those of you that haven't, make the trek. It's really worth it. It's gonna give you goosebumps when you're there. It's really incredible. So this is one of the oldest sites, right, in North America, definitely one of the largest. It was inhabited around 1700 to 1100 BCE. And it's these earthenworks mounds. You can see them. It almost looks like an amphitheater, right, back there. But it's a series of ridges. And if you were to lay these ridges out end to end, it would be 7.5 miles long, right? So these are really big ridges. And they're not natural, right? These were created intentionally. And this is right next to the river. And so these are areas that would flood, right? In the springtime, especially when we don't have levees, right? These areas flood. So a lot of older humans and indigenous humans would kind of have two homes, like a lot of people do today. You know, where I live down the road, our next door neighbors are lawyers from Baton Rouge that come down for the camp for the weekend, right? And hoop and holler and have a great time. Well, that way of life, having two homes, goes all the way back to deep antiquity, right? Because if you need to fish and you need to hunt, you want to be as close to the water as you can, right? And you're going to be up on the water. You're going to be on these ridges. You're going to be on these mounds. And then when, right, it's getting winter time, no more fishing, no more hunting, you're going to move further inland and more of your permanent residence, right? So this area here, like I said, those ridges were made by hand, and this is always really incredible to me. It's estimated that 750,000 cubic meters of material was moved by hand, right? And by hand, we're talking about a basket, right? One basket of mud and shell at a time. And these baskets can hold approximately about 50 pounds. So that means this is 30 million basket loads by hand intentionally. That's amazing, right? That's really amazing engineering. Of course, the LSU mounds right here, right, in Baton Rouge, are quite literally the oldest structure, right, in North America at about 11,000 years before present. So we've got a deep history, right, of living with water. Okay, slide, please. So where did it go wrong, right? Where did things start to fall apart? I love it when students ask me that question because it's complex. It depends on where you live, right? And how you define it. So down here, this is my personal opinion and my personal definition. I blame it all on Captain Henry Shreve, right? Because he really started to re-engineer the river, and I'm not sure he really understood the consequences, right, of doing so. Also, when you start digging into this history, you realize Louisiana has a dynamite problem. So it's kind of interesting. But in 1831, Captain Henry Shreve, right, which Shreveport is named after, he was a steamboat captain, right, bringing people up and down the river. And this bend in the river, okay, this is where the old river structure is, if you're familiar with that. So north of here. This bend in the river was the bane of his existence because it would take hours to go around this bend just to go that far, right? And he hated it. It drove him nuts. And this area where the Red River goes into the Mississippi, right in that bend, and you see the Atchafalaya comes off, that part of the river would collect huge amounts of logs, right? You can see this is a picture from I think it's from the 1840s, 1850s, but you can see a guy kind of standing in the middle way there in the back. So it gives you a sense of scale. But these log jams were really important in the Mississippi River. The Delta would get full of log jams too. It's interesting knowing this because now I don't even have to look at the Carrollton gauge to know when the river is up. The second I see logs on the river, I know the river's a little bit higher. So logs always tell you something. But these log jams would be important because they would kind of jam up the river and force the river to kind of move and spill sediment in new areas, building the marsh and building the land. Well, if you're a steamboat captain, you've got this gnarly bend that's full of logs and it's going to drive you crazy. So what are you going to do? You're going to get rid of them, right? He dredged his way through there with boats and with dynamite, right, to get rid of this log jam and to build a cutoff. You can see there in 1831. So just making his trip a little bit shorter. And in doing that, right, that set the stage for us needing the old river control complex that we need today. So when he started dredging all those logs out of there and using the dynamite, it temporarily started making the Atchafalaya deeper than the Mississippi. And so the river wants to go that way, right? And so today we have to keep them separate because of Shreve, right? Because of that work that he did. Okay, slide, please. Of course, he said, as Europeans get here, we are clamoring for all the resources we can, right? And so we have a story of natural resource extraction and disconnection from the river. So you can see over here on the left, right? lots of fur trapping and selling, which we know later brings in the nutria, right? So once all the muskrats were taken, right, were sold, we had to bring in something else, right, to keep the fur trappers busy. Of course, we removed all of our old growth cypress trees, which if you've never been to Cat Island to see the oldest tree in Louisiana, the oldest cypress tree, I urge you to, because that is a swamp that is converting. So I don't know how much longer a lot of those cypress trees are going to make it out there. So definitely go see it if you can. It's really beautiful. But these trees, you can see first the image at the top, how large they were. None of us in this room have ever seen a cypress tree of this magnitude, right? These cypress trees can live up to 5,000 years old. They're huge, right? They're relatives of the redwoods. They get big, right? But they also have tannins in them, right? Which makes them resistant to termites, which makes them water resistant. So we're going to build everything we can with it, right? And so the scars from taking these logs out of the swamps is still visible today. This is an image I took from Google Earth, right? You can see it. So all of those lines going through the marsh there is where they had boats cutting these trees down and literally dragging them right through to the sawmill. And so you can go, like I said, on Google Earth and see, right, these scars from taking it out. And then over there on the right side, of course, we wanted to increase river production, right? Getting ships, certainty of commerce, right? Ships up and down the river. So we built the Mr. Go, right? The Mississippi River Gulf Outlet, which of course later is what gives us massive destruction, right? In New Orleans East after Hurricane Katrina, when that water could just funnel through. I really love this image. I hate it, obviously, but I really like this image at the same time. Because I don't know if you guys have ever seen Dr. Strangelove, but this image really almost seems like a comedy image. You got this giant dynamite thing. All these guys are dressed in suits out in the swamp, pushing the lever, right? Destroying all of the swamps behind it. Today, that is open water, right? It doesn't exist anymore. Slide, please. So let's revisit those salt domes, right? We talked about at the very beginning, the very bottom layer, right? These salt domes are important, not just because it gives us Avery Island and Tabasco and all that great stuff, but I told you those salt domes like to come upwards, right? They're low density. So when you start to put a bunch of rocks on top, it moves up. Now, in the rocks that were above these salt domes, okay, there's a lot of oil and gas that's trapped in those rocks. And you get kind of these alternating layers of sand and then harder rocks. And the oil and natural gas gets stuck in the sand, but these are flat layers. Now, I know how hard it is to get sand out of my car. I can't imagine how hard it is to get oil out of sand, right? That's tough. So when these salt domes move upwards, right, against these layers, it will tip those layers as it moves up. When it tips those layers, you can see over there on the right, kind of where the black area is around that salt dome. That's where the oil and gas collects because it's lower density than the rock. So it moves to that upwards position. Those salt domes is what honestly allows us to extract all of the petroleum out of the Gulf. If it weren't for these salt domes, it would be really, really hard to do so. We could still do it, but it would be really difficult. And you would not like to fill up your gas tank. It would be very, very expensive. Okay, slide, please. So as soon as we realized, right, we could extract all of the oil and gas, right, from around these salt domes, we went to work, right? There is more than 10,000 miles of pipeline canal that has been dug through our marsh. Now, when we think about the bayous that we've talked about before, right, all the distributaries, are any of them straight line? Do you know of any river that's straight? No, of course not. We live on a round planet. Things are going to move around, right, as such. Now, when we dig these pipeline canals, we're going to go straight as the crow flies to have the shortest distance, right? Because every mile you dig costs money, right? So by creating these straight lines, as you can see down there in that bottom picture, and that's just a picture taken from Google Earth, this allows saltwater during hurricanes, during tropical storms, even sometimes just a strong south wind to move further into the marsh. If you've got a curvy bayou, when that water gets pushed in, it's going to slow down around those curves, just like a NASCAR driver, right? It's got to slow down around those turns. But when you have a straight line cut across that marsh, that salt water can go straight in, right? And much deeper into the marsh. And the marsh, when we think about it falling apart, right? You've heard of land loss. We all live here, right? It doesn't just fall apart from the outside, from the waves. When that salt water gets into the interior of the marsh falls apart from the inside out. Because salt water in a fresh marsh, right, where the plants love fresh water, those plants are going to die, right? The second salt water hits them. And when you lose those plants, those roots go down into the ground and hold that material together. And so when you lose the plants, you lose what's holding the ground together, and it just starts to fall apart. Okay, slide, please. Then, of course, this brings us to the Great Flood of 1927, which, hard to believe, we're almost at the 100-year anniversary of this huge flood that left over 600,000 people homeless. If you haven't read about this, definitely connect with me. I will send you some papers, because this is, again, only 100 years ago. So there's a lot of human written accounts of what happened during this time. And this was just a normal springtime flood, right, that happened. Just like, when we have to open the Bonnie Carey when we get too much water, right? This big flood happened. And we know that it takes a matter of time for that water to get from the north down here, right? So we can see it coming, we prepare for it. Well, what happened was a lot of the landowners or a lot of the business owners in New Orleans were really nervous, right, about this great wall of water that was coming down. And they didn't want their businesses to be flooded. At this point in time, we didn't have the Army Corps of Engineers making levees up and down the river. Levees were built by private landowners, and there was no standards, right? It's not that you had to build a levee on your property 10 feet high. There was nobody to enforce that. There was nobody to even make those rules. So we didn't have any levee systems, right, per se. So as this wall of water comes, right, the business owners petition the governor, right, to blow a hole in the river somewhere, right, to alleviate the pressure that they know is going to come. Now, the engineers were definitely against this because the river always blew up there at the Red River where Captain Shreve did his business. That's a weak spot in the river. So when those big walls of water come down, that's where it usually goes, right? That's why we have that big structure there today, keeping it from doing that. So, of course, money always wins, right? So the governor signed the petition, right, got it all going. They blew a hole in the levee, which you could see over here on the left, and that is in St. Bernard Parish, right on the St. Bernard-Plaquemines Parish line, which was a very poor community, right? Not a surprise, right, that they chose to detonate the levee into a poor community. And there are actual accounts of people filling up their horse-drawn wagons full of everything they own because they knew the water was coming once that levee was blown and trying to get out of town, while you had the more wealthy people from New Orleans quite literally in boats on the river waiting to watch the spectacle. So it's a really wild dichotomy, right, between the two. But this is where things, like when we talk about Katrina and you hear these stories about, oh, there had to have been a barge and dynamite. Well, this is why those stories exist, right? Because it happened, right, at points in our past. So we have the Great Flood. Then after all of these homes are lost, right, basically the government said we can't do this again, right? We have to come up with something. And this is when our levee system started becoming in place, right? So we have levied up the river. We have straitjacketed the river from the tip of Illinois all the way down to Venice, Louisiana. And that's what you can see in that top right picture. Again, why the river has built all the way out to the edge of the continental shelf. If you look right past the Birdfoot, you kind of see that really kind of marbly, boily looking area. Those are the salt domes, right, that are out there. But then you see it gets to be deeper water. So all of that sediment's now just going off to the edge. And I just put in that picture of Fort Proctor because I'm pretty sure it wasn't built in water. Right, so you can definitely see the subsidence. So subsidence is just sinking. Subsidence is a natural process. This is how we go from loose rock, like loose sand, to sandstone. It gets compacted over time. Well, when you live in an area like this, when you have fresh sediment that's full of water and it gets compacted, Generally no big deal, because in the spring, the river is going to bring a whole bunch more sediment and it's going to build on top of that, right? So you don't really see that you're sinking. However, when those levees came in and we shut off all these distributaries and bayous, there was no more sediment going out, right, into these marshes. So now we're just sinking, right? There's nothing to rebuild. Okay, slide, please. Of course, hurricanes don't help us by any stretch of the imagination, emotionally, physically, land-wise, right? They're pretty tough. We lose a lot of land, right, during hurricanes. A lot of marsh gets wiped out. A lot of our flotant, right, the floating marsh gets wiped out. During Hurricane Katrina, or during Hurricane Ida, you can see up there in that top right picture where those squares are, a lot of that flotant washed out and quite literally washed down to the end of the river. We were in a boat just a few days after Ida. My partner and I were delivering food down to the southern end of the parish by boat because the roads were underwater, so it was more efficient to go around. And it was literally like in the industrial canal, which is kept open, right? There's no marsh in there, right? Because that's where the ships go. It was full of so much flotant, it felt like we were an icebreaker trying to get through, right, the flotant. But it all came from Terrebonne and Lafourche Parish. Okay, slide, please. Of course, invasive species don't help either. You see how this problem just compounds, right? When we disconnect ourselves from the river and disconnect ourselves from the ecosystem. So all these images you see up here, these are all invasive species, right? These are organisms that aren't native here. And the problem with that is that the organisms that evolved to be here are here because they can eat the plants, they live with the environment, everything is compatible. When you have an invasive species come in, it will take all of the resources away from those native species, kind of breaking down the food chain, and it kind of creates this big domino effect, right? So you can see everything from those hogs right up there to some of my other favorite, like fire ants. Those are invasive. Although fire ants do kind of have like a pretty gnarly way of dealing with water themselves. So what you're looking at there, that's a floating ball of fire ants. I don't know if you guys have ever seen this in your yard at some point, but the ants on the bottom will quite literally die for the sake of the colony and create a raft for all of the other ants to get upon, and they float. Now, the problem with this is you don't want to be the solid ground that they find, right, when they find solid ground, because I have seen cows in Plaquemines Parish completely decimated and like stripped from fire ants. They will definitely, in mass, they will kill you. They're pretty bad. And then, of course, the nutria, right, like we mentioned before, brought in for fur trapping. Okay, slide, please. Then sometimes we have natural things that happen, right? These are things that are natural parts of the system that aren't human induced, right? We have some faults here in Louisiana, not like personal faults, but actual rock faults right here. We don't have anything like the San Andreas, right? We don't get big giant earthquakes. But because the delta is settling at different rates, right? We've kind of kept everything in place. We have a lot of faults that have developed. We have the Baton Rouge fault zone, which here we are, right in Baton Rouge. And if you look at that top picture, it kind of runs along that red line up there, which basically, if you paid attention during the delta building, when we talked about all those deltas moving back and forth, they moved back and forth below that red line. So everything above that red line is kind of older, more solid rock. Everything below that red line is a little bit looser. It's not solid rock yet, right? And loose rock doesn't stick to solid rock very well. Okay. So what is happening over the course of time, and this is a very long time, it moves about 0.5 millimeter a year, so it's really slow, so no panicking, is everything below that red line is eventually going to fall off into the ocean. Isn't that fun? Yay. That was sarcastic, but in any event, and we've seen this before in geologic history. So if you look over here on the left, on the very left, you see that word Lobo megaslide over there? This happened to the entire coast of Texas. It sloughed off like a calving glacier and just fell off into the ocean and created a giant tsunami across the Gulf. And you can see the tsunami deposits in Florida. That's pretty wild, right? So the fault here isn't going to help us, but this is a much longer term problem, right, than our daily existence. Okay, slide, please. Now, if we look at where we are currently and where we're going to go, we know we have problems with water, right? So here's where we are currently with our sea level rise. You can see all the blue there. This is where we are at. Slide, please. We know we are expecting about 18 inches of water by 2050 with sea level rise. And you can see how many more spaces, right, that water now occupies. Okay, so the long and short of it is we have to get good at living with water again. Okay, slide, please. There's hope here, right? We know that we can live with water. We can reconnect to the river. Here are some natural crevasses that have occurred. Mardi Gras Pass is a crevasse, which is a hole in the levee. It's a French term, which reconnects the river back to the marsh, basically. And you can see there in that picture progression how much land it is built, just naturally. This is not a human engineered structure. This is just nature being nature. Okay, slide, please. Then we have Neptune Pass, which is literally right across the river, right from where I am at. And in just a very short matter of time, it has built about 3,200 square acres of subaerial marsh, which means it's right below the water. If we could let Neptune Pass go for another 2 or 3 years, we would have plenty of land right above the water. And the area that it's building in is called Quarantine Bay. That area used to be 6 to 12 feet deep. And now you can go out there at low tide and like play a soccer game, right, on some of these big flats that are there. Slide, please. Of course, we can mimic this as well, which is what the hope of diversions are. And of course, diversions are in the news right now a lot. But a diversion was basically going to do what Neptune Pass and Mardi Gras Pass are doing, right? Reconnect the river, but in a little bit more controlled way, right? So we're kind of pulling the reins on this one. But we can do this, right? We can work with nature. We can rebuild some of these areas, or at least buy us a little bit more time, right? So we can figure out our human plan. Okay, slide, please. And with that, I will leave you with my favorite image, right? These are all of the watersheds in North America. Pretty easy to pick out the Mississippi River, but this is a fun game I like to play in the evenings of picking out rivers and seeing if you can name them. So it's kind of fun. So thank you guys for your attention this evening. And if you have any questions, I'm always more than happy to answer.
Yes, thank you so much. That was very interesting and informative. Do we have any questions from the audience? Yeah, and I'll bring the mic over to you so she'll be able to hear you.
I have a question about the nutria. They were brought in because the muskrats were taken out by for their fur, and so they had to have something to, and so they were imported. You know, there was, I guess, a story going around that one of the hurricanes let them out of captivity, and so now I know the real reason why they were brought here.
There's definitely a lot of like folklore around many of the invasive species, but yeah, nutria were brought in just so the fur trappers could continue to have an economy, right? Because their fur is like muskrat, it's waterproof, right? It's going to do the same thing. It's going to make nice coats. But then what happens when fur trapping stops is the nutria, population exploded. Today, though, down in Plaquemines Parish, we have the Nutria Rodeo, which I encourage you all to attend. It is a wild time by all stretches of the imagination, but it's just like a fishing rodeo, but for nutria, and they go out and shoot thousands of them. And whoever catches the most wins a prize, the biggest one, all that kind of stuff. And it works, right? Because there is a guide down there that brings people, like people will pay to go shoot nutria, right? They'll pay to go shoot hogs, all that kind of stuff. And he's really angry that there's less nutria to shoot because people are paying to do this. But the point is that it's working, right? And Quipra also has an amazing program too, where if you shoot and kill them and chop off their tail, you get money for it, right? So was it $6 or $7? $6. And so there's a lot of like shrimpers and crabbers that do this on their off season. And man, that really helps. So we're not really trapping for the fur anymore, but we're trying to get rid of them. Mhm. Yeah, yeah. Crabs love nasty, rotten everything. Mhm. But the nutria from the nutria rodeo, just so that way nobody feels bad about like all these dead nutria, they're brought to the Audubon Zoo and fed to the animals. So that's not like they're just dying for nothing. Yeah. Thank you for the question.
Oh, we've got another question.
Yeah, one thing I wonder about with the Barataria diversion, with all the water from the Mississippi going in there,
Mhm.
how pure is that water? I mean, wouldn't it include an awful lot of runoff from the rest of the country and with all the chemicals and so forth that might come down? Has that been taken into consideration when they're planning that thing?
Yeah, I mean, we're currently drinking it. So if you have worries about the contamination in the water, it goes a lot deeper than mid-Barataria, right? The water that I drink in Plaquemines Parish literally comes straight from the river. So, I would highly suggest everybody look at their water grade because there's definitely a lot of issues. But the thing is that if we have healthy wetlands, wetlands are a filter, right? They're a fantastic filter. And so once we have mid-Barataria come out, right, it's going to build a huge amount of wetlands, right? 50 square miles of wetlands. Well, that's a huge filter to help filter the nasty chemicals that are going out and that your shrimp are eating, that your crabs are eating. So really it's helping buffer that, right? It would help reduce that in the long run than just continue to have the high levels that we see today. It's a very good question and a very important question that goes a lot deeper, unfortunately.
Any other questions? I think on the invasive species slide, you had a picture of a nutria, I mean, not a nutria, a leech, is that right?
Oh, those are the the hammerhead worms. So they're actually worms. I've not seen one in person, but they're really gross, but they're invasive and they'll eat. Now, look, earthworms are also invasive. I don't know if you guys know that. They were brought here with Europeans, which is really interesting because when you look at like old historical records, the leaf litter that was here in North America before earthworms was huge. There's like records of people quite literally like wading through leaves because there was like less decomposers. So worms are also invasive, but these worms are pretty nasty. They can change the soil chemistry and get rid of a lot of bacteria and a lot of other insects in the soil. They're all great questions. I really appreciate it. Yeah, there's another question up here.
A previous next door neighbor of ours was a civil engineering professor at LSU, and he worked with the Corps of Engineers with the old river structure. He was adamant that man can control the river. And I'm watching all the ways the river has gone all over the place. Can we really make it go where we want it to go, or is it going to take over eventually in its own way?
That is a great question. And I think one that we wrestle with, right? I feel, and this is my personal opinion, right, that man has a lot of hubris thinking that we can control something that has been here long before our existence, right? Now, can we help it along? Absolutely, right? I feel that we should be doing a little bit better of a job as engineering with nature as opposed to keeping nature at bay, because we can guide the river or guide, distributaries and bayous into places that are needed and let the natural processes occur. But it's really a fine line between, we're going to put all of this concrete here and this is where the river is going to be. Well, it's not going to be there forever, right? There's also going to come time if we look in the deep future, humans won't be around at some point, right? We will go extinct, hopefully not anytime soon, right? But we will, and nobody's going to be here to control it, right? So it's really, in my opinion, a lot better to work with nature than thinking that we can truly control where it's going. So I'm not sure if I really answered your question 100%, but we can maybe control it within our own personal lifetimes, but not much further than that.
I'm sorry. There was an article this week or last week in Science Magazine about that cities that have been lost as a result of these dynamics. Settlements, I guess. I don't know how big the cities were. And the article was pretty clear that there's nothing we can do, that these processes are way too powerful.
Yeah, there's definitely, I mean, you saw, right? The nature is going to do what nature does.
Right.
For sure. But there are things that we should be doing to help, right? As in lowering our carbon footprints, right? And I'm not necessarily talking about us in this room, but giant industries, right? Those are generally the ones that are the culprits, right, of climate change. So there are things that we can do. There are things we can do to help restore the earth back to, closer to a pre-industrial age, which we should be doing that. I would hope that at this point, all the alarms and bells and whistles should be going off in everyone's head, right? That we can do that. But yeah, so even if we didn't taint our atmosphere by any stretch of the imagination, right? We lived with water. These processes would happen, right? The delta would change. We're at that age where the Mississippi River would want to go somewhere else because it's kind of reached as far as it can go. It can't go any further. And we're seeing that with things like Mardi Gras Pass and Neptune Pass. The river's trying to break free. And it's going to continue to happen no matter how many rocks we throw in a hole, right? It's going to continue to happen until the river gets where she needs to go.
And so in New Orleans, they're building along the river for the port. And you got to wonder, wow, is this smart?
Yes, I live in Plaquemines where we have a nice shiny new LNG facility that's built on top of an old lake bed, which is the lowest spot in the entire parish. And they were allowed to build a whole wall around their facility, right? So that tells you what they're expecting. But at the same time, I can't build my house on a mound, right? That's not allowed. So there's definitely a lot of questions I have as well.
Are there any other questions? Well, if not, thank you so much. And please come back to our next program.
Thank you all.